This episode is brought to you by Morning Brew. Possibly the biggest difference between detecting a ship in space as opposed to on Earth is that there is no horizon to hide behind, except perhaps for a black hole's event horizon. Probably one of the most popular tropes in science fiction is the idea of the stealth or cloaked enemy vessel, station, or even planet. For today's Sci-Fi Sunday, I thought we would explain why stealth in space is considered so difficult to achieve, and discuss a few of the possible workarounds to each hurdle to hiding things. As always, this will be a detailed discussion of the topic, so if you can slip past your housemates unnoticed, go discreetly grab a drink and a snack and settle in for a while with us. I want to emphasize though that under known science, the burden is high for achieving stealth, and a lot of the workarounds will qualify as what we call cloak tech, technologies so advanced they are indistinguishable from magic, and probably technologies that will be fictional for a very long time, and maybe forever. With that in mind, it is a good choice for a Sci-Fi Sunday, since we tend to relax how stringently we stick to known physics compared to our regular Thursday episodes. We probably need to start by asking what we mean by stealth. We are talking about hiding a spaceship from physical detection from an opponent, with roughly equal resources and technology. I feel this is a fair point to emphasize on the grounds that your biggest motivation for stealth in science fiction is usually trying to sneak to seize tactical or strategic advantages, and you do not need those if you are some advanced civilization going up against one much younger, smaller, and less technologically advanced. You can just go in and kick their butts. And sneaking up on your enemy can be reserved for when you don't already have armadas orders of magnitude bigger, each composed of ships able to destroy their armadas single-handedly. So we are talking about stealth as hiding physically from a technologically equivalent watcher, but we will exclude trickery like getting an inside man in to shut off their detection grid, or feed it shovelfuls of garbage data. Note that these two are exceptions to our no stealth in space rule already, and neither should be ignored. Anthropological surveying of primitive alien worlds might require hiding from the natives, and certainly implies no parity of technology on their part. So too, an awful lot of sneaking and stealth in modern and historical contexts is achieved by trickery or bribery or so on. Another option for sneaking in undetected is to be trying for a level of stealth deemed to have a prohibitive cost to benefit ratio for detection. In other words, your adversary could detect any vessel you send at them if they are willing to dedicate unlimited resources, technology, and manpower to watching for it. But there is always going to be a point at which their expense of bigger detectors, more detectors, better processing of data, and vast manpower exceeds the desire for it or their resources. As an example, if the defense agency deems the most stealthy threat to your solar system to be a relativistic kill missile, or RKM, and deems themselves able to safely destroy one a light day out without endangering those in the inner system, and the current grid already allows detection of them fully a light month out, it is hard to justify the need to expand that grid out to a light year. You might do it anyway, but if the junior senator from Pluto rises to ask for quadrupling the defense budget to build a grid able to detect them a light year out and maintain that extended network for decades or centuries, some might argue that it is pointlessly expensive. The counter-argument might be that the detection level necessary to see an RKM that far out was also what was needed to see some unknown but plausible new threat under development, or perhaps even an indirect threat like a small probe that might latch onto an Oort cloud object where it could quietly hide and spy on the system. So a bigger grid was necessary for those, the unknown threat and the spy. However, that might be deemed the sort of thing that just wasn't worth preventing. Trying to stop unknown unknowns or keep them from spying on you, especially given that enemies with little intel or bad intel on their neighbors often act dangerously erratically, as many argue often happened in the Cold War. Sometimes you want the enemy to know what you are doing, and not for the purpose of intimidation or misdirection, since having them think you are building a giant fleet when you are not might make them act desperately to counter that. There is also something we said about openness as a policy as an alternative to stealth. In the Star Trek setting, at least in the mid-90s TNG and DS9 eras, we see the Romulans and Klingons both possessing stealth technology, cloaking fields, but the Federation not having them. There are some contradictory reasons offered for this, but the main presented reason is a treaty between the Federation and Romulans that the Federation won't use cloaking technology. On the surface, this sounds like the sort of negotiated deal that only happens when you just unconditionally surrendered after losing, or your negotiators turn out to be taking bribes from the other team. However, it is worth noting that we do not know what the Federation might have gotten in exchange for that, and one also has to acknowledge that while cloaking technology very much fits the sneaking, conniving Romulan civilization we see, with lots of intrigue and misdirection throughout their culture and government, it is the polar opposite to the way the Federation normally acts and idealizes. For longtime Trek fans, it's fair to say that a cloaking field doesn't really benefit the Federation much. They already have holograms for hiding from low-tech civilizations they are studying, for obeying the Prime Directive, and that's their only real desire for stealth. Examples like Section 31 aside, the presumption on the Federation is that it's pretty open about what Starfleet does, and genuinely respects concepts like the people have a right to know. The Federation's whole modus operandi is non-stealth, and they probably assumed with good reason that they could nullify the stealth edge when needed. Indeed, depending on the episode, they seem to have a detection grid in place that at least alerts them when cloaked vessels enter the neutral zone. Alternatively, their society isn't well configured for keeping secrets, so stealthy bases on the enemy's border, or those of prospective new members and allies, would probably be detected through espionage, or even just reading the newspaper. The cloaking device tends to be pivotal to a lot of debates on how the Federation does things and acts as a proxy for how we ought to do things. Personally, I'm opposed to the Prime Directive, and I don't approve of spying on natives because I wouldn't approve of my neighbors spying on me, but the Federation at least offers a reasonably ethical reason for hiding themselves from primitive cultures. I emphasize that because I mentioned how a civilization is bound to draw some sort of risk versus cost line on how big and omnipresent their detection grid needs to be. But they also might not like the idea of their own government being quite that omniscient, since it might turn its eyes on its own citizens too, and thus they might build internal blind spots in. Indeed, that same sort of acceptable or even intentional weakness is what enemy saboteurs can take advantage of. Such being the case, you might even limit your external capabilities somewhat in acknowledgement that the new extended detector offers minimal advantage, but the enemy could easily hire a mercenary strike force from your own population to go blow it up for 1,000th the price you pay to maintain it. Now, those are some ways you can sneak around without needing to be stealth, but we're really interested in physically hiding right now, and that's very difficult. To explain why, let's start by pointing out that the light coming from the dimmest stars visible to the naked eye hits Earth with a brightness per unit area of about 20 nanowatts per square meter. In relative terms, we can see the star Vega very clearly even though it's 25 light-years away, or 240 trillion kilometers away. It is the second brightest star in the sky, and the one whose apparent magnitude is set as exactly 0 for that scale. It gives off roughly 16 times 10 to 27 watts of power, 40 times what our sun emits. It would drop off the edge of naked eye visible if it was moved about 20 times farther away, where it would be 20 squared or 400 times dimmer. In other words, something 400 times dimmer than Vega appears in our sky would be just barely visible to the naked eye. Needless to say, we can do a lot better than the naked eye, but as an example of the visibility of spacecraft, the old shuttles on takeoff emitted around 12 gigawatts of heat and light as they launched. Vega is more than a billion times brighter than that, but because light falls off with the inverse square of distance, the shuttle would be roughly as bright as Vega when it was about a billionth this far away, or about 277,000 kilometers away, nearly as far as the moon is. The shuttle should still be naked eye visible over 5 million kilometers away with main engines on. Keep that in mind when next reading a sci-fi story about a daring smuggler landing their ship undetected on a planet. Our best modern optical telescopes could see that shuttle-bright object about 10,000 times further away, incidentally, out at distances we only discuss in terms of AU or light days, 360 AU or 2 light days, about 10 times the distance to Pluto. We might assume more advanced civilizations have better telescopes than our current ones. Obviously, you would have to be looking right at the object to see it, which is a distinct limitation with a telescope as it necessarily has a very limited range of view, but it illustrates a point that is probably as relevant as the claim that there is no stealth in space, and that is that any stealth you had is gone the moment the searcher has good reason to point their gear in your general direction. It is also important to understand that the shuttle's drive is far too weak to do anything like the maneuvering that we see on your typical stealthy sci-fi spaceship. They need more power than that, and a powerful engine emits either EM radiation or very hot gas that gives off EM radiation. but their only methods for stealth are either to find some way not to emit it at all, to direct most of it in a way that will miss the enemy's detectors, or to have that power come out of something they cannot detect. Your eyes, for instance, can't see infrared light or radio waves, and while we can make instruments that can see those, we have a hard time seeing neutrinos and still can't see dark matter. So if your thrust is coming out as neutrinos or dark matter, you would be quite stealthy to us, but it also implies you have a material for deflecting, reflecting, or absorbing neutrinos or dark matter, and those are capable of interacting with those particles by definition, so you can also use them to build detectors for those particles, which triggers our early caveat about how we aren't discussing your ability to be stealthy to a sorcerer whose technology is way inferior to your own. In other words, if you can build a drive based on some exotic technology, assume your adversaries can build detectors based on it too. This is usually much easier. The thing is, even these seemingly invisible things as propellants, invisible to us anyway, still would not result in a ship we could not detect. Everything in known physics emits light, and truth be told, even black holes are not really an exception to this, not in a practical sense. The frequency of that light can vary. Ultra-hot things can emit frequencies far higher than our eye can see, like ultraviolet or even X-rays or gamma rays. Colder objects emit frequencies far lower than we can see, like infrared and microwaves, but nothing can really stay as cold or colder than the ambient local temperature, and that is 2.7 Kelvin everywhere from the cosmic microwave background radiation, and in fact higher inside galaxies and higher yet in the solar system. We can detect microwaves, and we could detect something that was somehow even cooler and gave off radio waves as this black body radiation. This is the light emitted simply by an object having a surface that is not at absolute zero. As a quick note though, this is not totally undetectable, but it is pretty dark. An object at a mere 5 or 6 Kelvin, double the CMB, but probably as cold as you could plausibly get the hull of a spaceship to be for an extended period, even with everything shut off including life support, would emit less than 100 microwatts per square meter, several million times less than the infrared emitted by a room temperature object per square meter of surface area. Very weak, but remember what we calculated with seeing a star or space shuttles. A cell phone or walkie-talkie or Wi-Fi router is only broadcasting 10 to 100,000 times stronger than a single square meter of that ship's hull is emitting. That ship is probably a lot bigger than a square meter. Remember that we could hear the Voyager space probe even after it went past Pluto, and its radio transmitter was only a bit stronger than your cell phone. So everything emits light, in some frequency or another, and that frequencies and spectrum it emits tells us a lot. Indeed, you can calculate speed off the redshift or blue shift of the light off from what you would anticipate from other characteristics of the ship or object. Not only does everything emit light, everything also has specific amounts that it reflects, absorbs, or transmits light through itself, and for any given frequency of incoming light too. This means it's very hard to be stealthy against someone engaging in an active scan, which is where you emit light at an object and see what bounces back rather than just what hits it naturally. A couple things folks forget when discussing this topic a lot. First, they are not limited to detecting return signals from the emitter, which is how we can outfox a lot of terrestrial radar systems with clever bouncy of radar signals hitting an aircraft. Especially if it's their home system, they probably have millions of satellites scattered all over the place that can pick up scattered signals. You have to remember the plausible scale of such civilizations. They really ought not be tiny little villages on a single planet in an otherwise empty solar system. They probably have billions of space habitats on, in, or around every hunk of rock in that system, home to quadrillions of people all living on an economy powered by cheap energy and smart automation. They don't have a starship or two out patrolling deep space and a few defense satellites. They've got scouts, vanguards, and picket ship squadrons that would probably dwarf the typical high-budget sci-fi films displayed armadas. And you have to remember that scale. When they send out an active signal, if they want to, they can be pinging a pocket of space with thermonuclear warheads, not flashlights, and probably have directional detection beams that can turn gigawatts of power on some tiny volume of suspect space whole light years away. But suppose your ship has a magic ultra-black hole that can absorb any frequency of light it encounters. That's great, now gets warmed up by that light and emits black body radiation. Your ship was already emitting black body radiation, so the increase in frequency tells your enemy even more about you. Okay, instead your ship can scatter light, perfectly reflect it and away. This is also great. Your enemy probably has probes and detectors all over the place, especially in their home turf. They probably also know about the trick of using a signal as their active detection emission, so you're not just bouncing some random light off, you're bouncing at a specific frequency with some pattern in it too, like the time the signal was sent at and the ID code of the sender. Now 2 other detectors at different angles pick that up, and between the 2 of them, they know exactly where you were when that signal bounced off of you. That does leave being transparent to light, but we'll come back to that. You also have to worry about blocking ambient light, all those stars behind you, and while you can simulate those by having lights on your hull of the right wavelengths mimicking the spectrum of the star you would be blocking, that obviously only works on one single line of sight. Folks off to the side wouldn't expect you to block that star and would think it weird to pick up that frequency. That said, that is a good way to sneak toward a star system. You come in from the direction of a very distant and bright star, or a galaxy or nebula that's a bit of a blob, and because solar systems are huge but still tiny compared to interstellar distances, this means that you have to be pretty close, in interstellar terms, before the folks on Mars or Ganymede will notice that there's a dot in front or just the edge of that distant hypergiant or galaxy that isn't quite reading what it should or is not reading what the folks over at Venus or Neptune are getting. Indeed, this is one reason we suggested colonizing the Oort cloud in the episode of that name. You would put detectors way out at light months of distance from each other, and vastly extend your parallax or how far out you could be seen reflected and scattered emissions. Using absorbed emissions would allow you to detect a ship passing through a beam of light between 2 places, and you could detect a break in that light beam if you had a signal in it and was spinning around and reading its scatter or lack thereof from drops when something absorbed it for a brief instant. There was a caveat in speaking of light beams. A ship mounting several beam or laser arrays, each capable of emitting a picked spectrum, could aim one at Earth, one at Mars, one at Venus, and so on, so that each got a tailored spectrum. In this way, each can be fed a different beam mimicking a different direction tailored to what you want them to see. This trick would only work if you knew where their detectors were all at, and would be hard to pull off. But the same as you can't hide from them normally, their detectors are likely to be known to you too. So everything emits light, and everything reflects, scatters, and absorbs light. Everything moving through space also has to move through everything in space too. By and large, a spaceship, while coasting, is pretty stealthy, especially compared to when it does anything to change its speed or direction. Any use of thrust is going to be a big signal flare, and will be hard to hide by imposing something between you and the other folks, like an asteroid, for 3 big reasons. First, let's say you're using an asteroid for cover. Light from your exhaust may not be visible, but you still have a big stream of hot gas blowing backwards. Hot gas gives off light, and gas scatters and absorbs light in a characteristic fashion, so your rocket plume is still very visible, and this would probably apply to most other drives we might imagine in some way too. Second, you're only invisible to the folks on the opposite side of that asteroid, so same as with trying to ride a star in its cover like we just discussed by mimicking a signal, anybody at a different angle is going to see you. And third, the faster you're going relative to that object, the less time you have for pulling any maneuvers. A rapid course change at interplanetary speeds will kill everyone in that ship, and if you're going much faster than tens of kilometers per second we consider interplanetary, less than 1,000th of light speed, you would even manage to kill cyborgs, posthumans, androids, or AI with such a tight turn. If you don't complete that turn that fast, they still see you. Turning behind something big and distant like a star helps, so fleets might alter course when they thought they had a star between them and their enemy, but their enemy probably would be aware that blind spot was coming and pay close attention. Don't rely on trying to turn behind a black hole either. They are actually smaller than such asteroids, and they won't hide your turn unless you make it inside the event horizon, in which case you are successfully stealth, but you would never get a chance to brag about that accomplishment. Conversations about stealth in space tend to often bring in black holes, and I would warn folks off assuming they offer any advantages for that. Black holes are not invisible. You would never have a shot of getting a normal black hole undetected anywhere near a star system, and beyond being visible in terms of their gravitational pull, in the electromagnetic sense they are just much darker than stars, except for when there's lots of gas and dust nearby them, in which case they can be much brighter than stars. And that brings up interstellar gas because it is everywhere, and denser in some spots, and it reacts to being hit by fast-moving objects. Space may be pretty empty, but when you are moving at a decent fraction of light speed, you are hitting a lot of gas and dust particles, and each is going off with energies comparable to atomic bombs or even antimatter in terms of energy release per unit of mass. This is not something that is terribly stealthy, and the faster you want to go, the bigger this signature is going to be, rising loosely with the cube of speed even before factoring in relativistic effects. If you go 10 times faster, each collision carries 10 squared more energy, and collisions with gas and dust are happening 10 times as often since you plow through 10 times as much space every moment. 10 times the speed, 10 cubed, means 1000 times the power signature of plowing through space. On the alternate side of this, the slower you go, the more time the enemy has to detect you, and the more time they have to act once you are detected. This does bring up one example of effective stealth though, because same as you often have to uncloak in fiction to fire your weapons, there is a point at which you are going to get detected and there is a point at which it no longer matters, especially if you don't have a crew on board that needs to survive. It is hard to throw a black hole at a star system without someone noticing, not just the gravity but the accretion disk it will pick up as it travels, and all the light and gas it will bend or accelerate, and all the signals passing by it that it will warp. Still, it's a lot stealthier than a star of equal mass, and it has an advantage going for it. It is really hard to do anything to stop a black hole rolling into your solar system, even with light years of advance notice. See our episode Weaponizing Black Holes for a lot of uses as well as counters and counter-counters of various natural and artificial black holes as weapons. So that's the basics of why we say there is no stealth in space. In one sense it is hyperbole, we gave plenty of ways you can hide, but in another it's one of those really ironclad statements approaching a law, like thermodynamics, entropy, and no free lunches or fast light travel. You need a perpetual motion machine or warp drive or time machine, various bits of cloak tech to violate those. To close for the day, those also offer some modes of stealth, but often the technology offers a means of detection too, which is why I put that caveat near the beginning about stealth only counting for opponents of similar technological prowess. A time machine can obviously let you avoid detection, you just jump back before their detector grid existed and blow up the folks who designed it, or the amoeba they evolved from. Some material that lets you turn into a phantom or ghost who doesn't interact with outside particles, be it interstellar gas or photons, might permit stealth but makes navigation difficult for you too. The tech that might permit you to navigate while in phantom mode probably can be used to detect ships in phantom mode too. A FTL drive or faster than light drive lets you arrive before the light you are emitting arrives, or the light they bounced off you as you approached. Some sort of perpetual motion machine, violating entropy as it does, might offer true cooling, even down to near absolute zero temperatures of nanokelvin, rather than our normal method of just moving heat around. A ship propelled by selected matter to energy conversion might be able to convert matter into beams of neutrinos to shoot out the back, and further aim them off in directions so no one directly behind them and pursuing them could detect them, or directly in front of them as they slowed to attack a planet. But beware assuming these offer no counter. If your ship runs by shooting some faster than light particle out the back, or communicates to home with such particles, then the enemy sensors can detect those particles. If you've got perpetual motion machines for keeping your ship eternally super cool, then the enemy has them for generating constant and powerful active detectors, and more importantly maybe for running their economy and factories to churn out endless armies of probes. We also need to keep in mind that for quasi-stealth options like slipping your ship in as a mundane natural object, or as one tiny ship with a fake transponder code around a busy planet's orbital space, this might work, but do need to be kept in context that such civilizations probably do have those swarms of probes and detectors and countless humans or AI checking for anomalies in data, but such pathways probably do offer a better chance for success. We never know what new science and technology might emerge to shatter this apparent rule about stealth in space, but hopefully by now it is clearer why this is so hard. Feel free to suggest and debate some scenarios for stealth in space with hypothetical technologies in the comments below, or for ways to do stealth under known science too, of course, if you can think of one. I've heard a lot of them suggested over the years, but if there's a way to be unseen under known science, I have yet to see it. So we were talking about stealth spaceships today sneaking up on us, and I suspect I'm not the only one who often checks my social media only to find out some new crisis or talking point has snuck up on me that everyone else seems to be talking about. On the other hand, it's just plain unhealthy to tune into the 24/7 doom and gloom news cycle. You need to keep up with the news though, and that's why I read Morning Brew. It's a daily free newsletter that gets you up to date on tech, business, and finance news in just 5 minutes, replacing dry, dense, and boring news with witty, relevant, and informative content, and in a fast fashion that lets me get up to date on the world in 5 minutes over a cup of coffee. So I can get updates on the current space race or how Bitcoin and cryptocurrency are doing, and again, all the content is free. It only takes about 15 seconds to subscribe. To envision the future, we need to stay up to date on the present, and if you're interested in business, finance, or tech, there's no reason not to subscribe. Just click the link in the episode description and start waking up with Morning Brew every morning. So we looked at hiding spaceships today, and on September 23rd we'll continue that discussion by looking at not just at hiding spaceships but entire civilizations, as we return to the Fermi paradox for hidden civilizations. Before that though, next week we will celebrate the 7th anniversary of our first episode, Megastructures in Science and Science Fiction, by looking at megastructural death on September 16th. Then we will have our monthly livestream Q&A on Sunday, September 26th at 4 p.m. Eastern Time, before closing the month out by asking if it's possible for future civilizations to exist without money on September 30th. Now, if you want to make sure you get notified when those episodes come out, make sure to subscribe to the channel, and if you enjoyed the episode, don't forget to hit the like button and share it with others. If you'd like to help support future episodes, you can donate to us on Patreon or our website, isaacarthur.net, which I'll link in the episode description below, along with all of our various social media forums where you can get updates and chat with others about the concept of the episodes and many other futuristic ideas. Until next time, thanks for watching and have a great week.